Hi everybody, this is going to be an unboxing, review, and maybe a partial teardown of 3 different BK Precision handheld digital multimeters. And what I want to do is analyze each one of these based on a very specific set of requirements and choose one of them as the best out of the 3 so I can buy a whole bunch more of them. Now, I work at a university as the electrical lab supervisor, and one of my responsibilities there is to maintain all the equipment that the students use for their lab experiments and also to replace it when it needs to be replaced. In this case, we've got a bunch of battery-powered multimeters that need to be replaced. We've got the Keithley 169 benchtop model and also a handheld, the Beckman Industrial DM25 XL. We've got some regular DM25 branded as a circuit mate instead of Beckman Industrial, but pretty much the same thing as this without the transistor tester and the capacitance tester. These are not the only multimeters we have. We've also got some good quality Fluke multimeters, the Fluke 189 and 87.5. The 189, by the way, has been recently obsoleted, but they all work just fine, as you would expect a Fluke multimeter to do. And we've got some Keithley 2000 multimeters as well, and they all work very well too. But these things are dwindling in their number, and they need to be replaced or at least supplemented. I don't actually plan to get rid of these things and all their brothers and sisters. I still plan to keep them and use them where they need to be used, but they should be supplemented with some brand new replacements. And we're going to go into the requirements for what I'm looking for right now. Okay, I broke this down into 3 parts. First, the requirements that I'm looking for, the 5 basic functions of measuring voltage and current, AC and DC, and of course resistance. That should be true for any kind of digital multimeter whatsoever. I want it to be manual range, and that's for the students' learning benefit, so they can actually turn a knob or push a bunch of buttons and actually grind into their head the very basic concept of ranging. Current range, less than or equal to 200 microamp. This one right here, the BK or Beckman Industrial, has a lowest current range of 200 microamp DC, and so that's what I'm looking for. It's got to be equal to or better than this. The Fluke, or I'm sorry, the Keithley also has 200 microamp current range right there, so it's got to be at least that good. Initially, I was looking at this one, the BK Precision Model 2707B, which does meet all of my requirements except for one, and that is the 200 microamp minimum current range. It's got 20 milliamp AC and DC. That's the minimum current, and that is absolutely pathetic as far as I'm concerned for my set of requirements. And then price range, $100 to $200. That's basically what I'm looking for, preferably on the side of $100 range. And again, these things are just going to be used for debugging 741 op-amp circuits or 7400 series logic or something like that. Really simple stuff. Don't need anything fancy. And also auto power off, and that's not going to be a problem in this day and age. But for the Beckman Industrial and also for the Keithley, we've got hard clunking switches, and there's no power off feature on these. And if the students leave them on accidentally for a long time, then of course the battery drains, and sometimes I just have to remind them right here, please remember to turn the damn thing off. Preferred features, true RMS would be nice. Fuses, inexpensive and easy to replace, because students, especially in the early stages of their education, just love to use current meter to measure voltage. So fuses blow in these things quite often, and I need them to be easy to replace and also inexpensive, not necessarily HRC fuses, especially for the low current ranges, because these really won't be used on high energy circuits. Diode check would be nice to check diodes, of course, and logic level for these digital electronic labs with the 7400 logic series circuits. You know, that's all nice. That would be a good, nice feature. And even nicer, bonus capacitance check and BJT beta check, just like what this thing has. Now for the unboxing and review, we'll start with this one right here, the BK Precision 2860A, which I bought from DigiKey for $105. And then we'll look at this one, which is a 388B for $139, and then for $199, just barely in my price range, the 391A right here. Alright, I had about 10 minutes of footage of just unboxing each one of these individually, but there's a lot of redundancy, so I'm just going to redo it here real quick, all three at the same time, all out of their boxes. And I guess I'll just start with the probes. The probe for the BK Survivor, that's what they call this thing, because it got the big fat rubber boot on here. And I'll go more into how crappy this thing is in a little bit. The probes for that thing are, you know, pretty crap quality, as you would expect for $100, less than $100 meter. And got these nice little sleeve protectors. There is one black alligator clip, not a red one. I have no idea why. I don't know if that's intentional or if it's just accidental that they included the black one and not the red one. A nice warning, this was straight on top as soon as you open the box. 20 amp current range is not fitted with a fuse in this particular meter. The other two do have 20 amp fuses on the high current ranges. And then instruction manual, no big deal there. The other two, very, very similar, that's for sure. They come with certificate of compliance and instruction manual. Each one is different. There's the one for the 388B and then one for the 391. It's not like a universal instruction manual for all four of the multimeters on the package here. And of course, accessory shopping things there. And then the probes, very flukish in appearance. We got the, you know, the red and black mixed with gray all around. The probes also have these little plastic tip covers to shield all but the point of the probe tip. And I noticed that the banana jack end of it has a plastic, it's either a plastic cap or the whole core of the banana jack is a plastic rod, or maybe there's a metal rod and plastic shielding going all the way around. And then of course there's the leaves, the spring loaded leaves on the outside of that to make good contact with the female connector. Of course, there you can see there's still the same red plastic cap on the banana jack lead there. Yeah, I think that's very interesting how they keep that completely insulated, so that even if you have these hooked up to energized circuit and this is just dangling on the other end, that these don't come in contact with anything else or with your own fingers. As for fuses, the BK Survivor comes with no extra fuses. The 391 comes with standard 1 1/4 inch long fuse, half an amp, and then the 388 comes with a 1 inch long fuse, 2 amp. And as for that single black alligator clip that came with the BK Survivor, apparently it's supposed to be like that, because here in the manual we say under optional accessories, deluxe test leads model TL-2, and if you look in the accessory guide, TL-2A, there's right there, black alligator clip included. And there's a picture of it right there, one single black alligator clip right next to the probe. I don't know what's so deluxe about that. What a crock. Now I've got something else to complain about with this thing, and that's the rubber boot. First of all, it's really bad how they have it, how it covers up half of the branding and the model number down there. That's just poor design right there. And let me pull it out. You'll notice that the tilt stand is actually on the rubber boot. So if you don't want the rubber boot, you're going to have to do without the tilt stand. And also, this thing smells like a freshly opened PVC shower curtain, fresh out of the bag. These other two multimeters right here, much nicer feeling blue rubber that's integrated with the plastic casing. And the tilt stand, also with the plastic casing, of course, it's held in with these two screws. So I took out those two screws. The one on the top is smaller than the one that was on the bottom. And the tilt stand comes apart into 3 different pieces when you take it apart like that. So there's this piece right here, which the manual refers to as a hanger strap. And it bends out a little bit like that, but that's as far as it goes. If you try to bend it back even further, it'll break. And I don't know. I mean, you could probably hang it, put a nail in the wall and then stick the nail in there, hang it like a clock on the wall, and so that, you know, with the feet sticking out, it'll be flush to the surface of the wall. And I don't know, put some kind of strap through there. It seems pretty useless, or at least if you do use it, it's going to break real easy. So that's pretty dumb. And I noticed some inconsistencies with the manual. This is for the 388, and that's what we're looking at right here, the 388B. And first thing I noticed, built-in probe storage. Obviously, there's no probe storage on this thing. And in the battery replacement instructions, step 3, remove the 2 screws. Well, first, after you remove the 2 screws for the tilt stand, step 3 is remove the 2 screws securing the case back. This thing actually has 4 screws, and there's really no reason at all to take the tilt stand off. It's just the 4 screws on the outside here, and you can take the whole thing off and have access to the battery and fuses. So I guess they got some updating to do on their instruction manual. Now let's have one big look on the inside of all 3 of these, starting with the BK Precision Survivor right here, the 2860. It's got 4 nicely threaded screws that go into threaded inserts in the plastic casing down there, and then there's these other 2 little dinky silver color screws that go into the plastic at the top here. These hold on the circuit board, and you need to take those out to have access to the fuse. Just got to jiggle that out a little bit there. So right there, I was surprised to find one of these big, fat, expensive fuses inside this thing. That's a 1 amp fuse right there for the low current range. Current shunt, 20 amp current shunt right there. And, you know, no fuse for that. And this, as well as the other 2 meters, they're all rated for 20 amp measurement at a maximum of 30 seconds. Because stuff, the fuse and the shunt and, you know, other things in here, they would overheat at, you know, greater than 30 seconds time. So it can do 10 amps continuously. All 3 of these can do 10 amps continuously. But any current higher than that, and you have to limit the duty to make sure that stuff in here doesn't overheat or overload. Another thing to point out is that there's a rubber gasket right here because it is labeled as water resistant. All the components on here are through hole. There's not a single bit of surface mount to speak of. Even the microcontroller for the LCD, that's a big dip package right in there underneath the LCD. And the switch, the selector switch, actually has traces, the switch contacts on both circuit boards, top and bottom. And I'm not going to take it apart any more than that. The input protection looks decent enough. I'm not going to do a thorough teardown and review, and I'm not going to go through, you know, all the circuit architecture like you would expect Dave Jones to do in one of his multimeter review videos. And the screws for those 2 blue multimeters just the thick threaded screw that goes straight into the plastic. There's no threaded inserts. And then as for fuses, you got the nice big HRC 20 amp fuse. And then for the low current range, in this case 2 amp fuse, right there underneath this plastic cover that just sits right on there. It's real easy to take it out when the cover's on, but when the back cover is on, there's these two little prongs right here that stick down and press onto this plastic cover to keep that in place. The battery, I like this. The battery is real easy to take out. Golden Power Greenergy, long life. And then on the 391 right here, you can see there's quite a bit different. Just about everything, like maybe the banana jack circuit board is the only thing that's identical between the two of them. The others, the main circuit board, completely different everywhere from top to bottom, even underneath the fuse right here on both sides. There's different stuff soldered on there. Lots of surface mount, almost all surface mount. Big differences between them here. And the 0.5 amp fuse, that's also underneath a plastic cover like that. Okay, before I put these things back together, let's have a little review of my fuse preferences being inexpensive and easy to replace. Inexpensive, well, obviously these two, the low current fuses, the 2 amp or the half amp fuse, those are more likely to get blown. Certainly not the 20 amp fuses. These would be unlikely to get blown at any point in a long time, over many years. I don't expect these to get blown at all. But these, much more likely to get blown, and these things only about $1, I looked up this one actually, and that came out to be 79 cents from somewhere, I forget where, but it's really cheap, not super cheap as in poor quality. They are ceramic casing, not glass, so pretty good half decent quality fuses. And this one, it's got the big fat fuse on the low current range, and that's going to be $5 to $10 easy to replace that. And just how easy is it to replace this? Well, I don't really like the two-step process where first you got to take out the back panel screws, and then you got to take this whole thing out with the 2 screws in the top corner, and then flip it over, and then you have access to the fuse. Whereas with the other 2 BK Precision DMMs right here, is just take off the 4 screws in the back panel and boom, you're there. Little thing here with the fuse cover, of course, that's no big deal. It just slides right off. I mean, there really is no clip or snap or anything holding these things in place. It's only when you put the back panel back on that keeps it down and keeps it steady. So if I was to eliminate one of them based on the fuse situation, it would certainly be the Survivor. Get that out of the way. And then there's these other 2. Well, they're pretty much the same as far as fuses go, except this one has a 2 amp low current fuse, and that would be less likely to be blown than the half amp, especially since most of the power supplies that the students use in their circuits are limited to about 1 amp or less internal current limiting. And so that means that even the 2 amp fuse would be very unlikely to get blown. So I'd probably hardly ever have to open this up if I was to get a whole bunch of these. It's unlikely that any fuses will get blown in electrical engineering student lab environment. Now I should also take safety into account. The 2 blue multimeters here have a Cat 3 rating on the inputs there, so that's pretty good. The yellow one here, the BK Survivor, has no Cat rating whatsoever. It does, however, specify in the manual that it is designed to stringent IEC 348 safety standards, whatever that means. So it's not looking too good for this thing so far. I don't think the BK Survivor is going to survive this multimeter shootout. Now let's have a look at measurement capabilities. We'll start with this thing, and it's, it meets my requirement of having the 5 basic measurement functions right here: AC and DC, voltage and current, and resistance. And then there's this one little position right here for diode check and continuity. And also, I'm not going to go through each one of these and, compare the accuracy of all the voltages and currents. I'm just going to, assume that it's all pretty good according to what it is in the manual. And as far as this thing is, pretty poor compared to a good quality Fluke or a Keithley. We're looking at around about 0.5% or 1% tolerance on a lot of these ranges. And that's, that's decent. That's really, I was actually, willing to accept that kind of relatively poor precision just for introductory engineering courses when students are poking around on their breadboard, just to make sure that the power supply voltage is plus minus 15 volts going to their op amp. That's really no big deal if it's plus minus 1% on the measurement. Anyway, we'll do the continuity test. Wow, holy crap. I don't know if there's some kind of oxidation layer on these probes or something here, but I can hold them down and it's very intermittent. So if I press down on the probes real hard, then we get some good continuity. But just poking on it like that, like Dave Jones does in his videos, that's really, really bad. These deluxe probes are not deluxe at all. Let's try the probes now from one of the other multimeter over here. Oh man, even if I just lightly touch the 2 probes together, it's still a very poor conductivity. Yeah, I really got to press them together to get any kind of response out of this thing. Diode check. I didn't check the specs for the open circuit output. Let's see if it can try a blue LED. Yep, there we go, but nothing on the display. What about a red LED here? Oh man, that's really, really dim, but there we go, 1.6 volt. So I guess 2 volt might be the maximum that this thing can output. Actually, the manual says maximum range of 3.2 open circuit voltage. So let's have a real good look at this thing. So clearly it's got to put out at least 3 volts because it was able to turn on that blue LED. But I have it hooked up to a voltmeter right here. If I turn it down to 0, it goes into continuity mode. But once it goes up to about 0.2 or 0.3 volts, then it turns into diode sensing mode. And we can turn it up slowly. There's 2 volts. Yep, cuts out at 2 volts and can't measure any higher than that, even though it still puts out 3.2 volts supposedly. And there's the 3.2 volts in quote marks that it's putting out. One handy feature that both of these things have is a warning buzzer sound when you're measuring current. I just plugged this into the 20 amp range, and if I turn this onto the 20 amp range selection right there, it's fine, but anywhere else, and it makes a annoying buzzing sound. And then if I put it here in the low current range input, then 20 amp, it makes noise, but all the other current ranges, it's fine. And then again, outside the current range, it buzzes and lets you know that you really ought to look at the at what you're doing before you proceed. This thing, however, has no such provision. There it is in the 20 amp, and I could put it on any range, voltage, current, resistance, nothing happens, no buzzer at all. Also, I should point out that my requirement for 200 microamp range is not entirely accurate, because this thing has 400 microamp range, and that's perfectly fine because it still works out to the same resolution as the Beckman Industrial, and the Keithley 169 have 0.1 microamp resolution, and so does this. Even this with the 200 microamp current range right there, 0.1 microamp resolution, or apparently maybe even better than that, 0.01 microamp resolution this thing might have. That's pretty good. Let me put this on here. Yeah, that's going to be 0.1 microamp resolution, and that really is my minimum requirement, not necessarily a 200 microamp range. Now let's try continuity buzzer on this thing here, the 388. Oh, nothing good there. Oh man. Wow, that's just as bad as the other one right here, the BK Survivor. I really got to press down on these probes to make it actually sound like that. Let me quick try it over here. We got a different frequency coming out of here. Wow, really poor continuity buzzer all around. All three of these, they totally suck. Let me try it with some genuine fluke probes here, just to see if it's a metallurgical thing here with the probe tips. Oh, you know what? I think it is the probes. The probes that are supplied with these things they seem to be at fault, because with the fluke probes here, this is much nicer. Even just a gentle touching of these things gives a half decent response. Same thing on here. And let's go back to the Survivor. Quite a bit louder than the others. Still much better response than with the deluxe probes, or even the whatever probes that came with these. I don't know. It's really weird. Alright, back to the original supplied probes, and we're going to go on diode check here on 388. So let's try a blue LED, and that turns on pretty nicely, and we get, look at that, 2.6 volt displayed on there. So indeed, this thing can actually display. Why don't we just hook it up to the power supply real quick. So I'm turning it up, and we've got 3.1. Look at that, it goes up to 3. Wow, it just keeps on climbing here. Oh, there we go. So 4 volt is the maximum that this thing can display. But in open circuit, it outputs 3.086 volt. And we'll just check it with this thing here. Oh, look, well, that's weird. Look at that. This thing says 3.086 volt. That's the open circuit, and going into 10 megohm, effectively open circuit, 3.337 volt. That doesn't seem right. We get the same thing over here on the Survivor. It's just really bizarre. And I wish I could compare that kind of effect with another multimeter, like a good quality Fluke, but every other multimeter I've ever encountered has always expressed overload when it's in diode mode and hooked up to nothing, open circuit. And the Fluke 85 is putting out 3.76 volts, but it doesn't actually display it right here. Whereas these things, you put them in diode mode, and, well, so that one doesn't display anything. Let me just disconnect this entirely and put that in diode mode. There we go. I don't know. This is the only one I've ever seen that actually displays the voltage, the output voltage, even when it's open circuit. Okay, mystery solved. If I have the diode check and a voltmeter and a decade box all in parallel, then I can turn this up to 2 kilo ohm, pretty good matching, 3 kilo ohm, pretty good matching. When we get up to 4 kilo ohm, then we're looking at 3.04 volt on the diode checker. So that's diode check. This is the voltmeter, 3.08 volts. Put this on 5 kilo ohm, and the difference just becomes ever more increasing. Look at that. So there's 10 kilo, or rather 100 kilo ohm now, and 3.07 volt is the maximum that this thing is going to show, whereas it's really putting out 3.2. So up to a certain point, basically up to 3 volts, it's going to be a 1-to-1 ratio. It really does display exactly what it's putting out. But anywhere above that, you'd really have to actually measure it to see exactly what voltage it's putting out. Let's do logic probe test, because that's another one of my preferred features for my selection here. So basically I've got it hooked up to power supply and measuring voltage with this thing, and then we're testing the logic function on each one of these. I've already noticed that on logic low, this one beeps. It does not beep on logic high. This one beeps on logic high, but not on logic low. So let me turn it down to 0 volts, and this one's making noise right now. Turn it up to about 1 volt, and it's quiet. And we'll keep going to 2.8 volts or so, and then this one starts making noise. And then as far as displaying the logic level, it's just overload right here and a 1 right there. The only indication you have is the down and up arrows, or no arrows at all, to indicate the logic level. Now we'll just check the capacitance tester. 0.1 microfarad. I think that's polystyrene, mylar, not entirely sure. We'll just put this on the, there we go, on the 4 microfarad range. Actually, it should be good on the 400 nanofarad range. Yep. Look at that. Nice clean 101 nanofarad. And the diode check, we'll put this on NPN, and I'll plug in a 2N2222. It's got a beta of 190. Not bad. Okay, I think I'm done with the testing now, and I'm just going to go ahead and say it. The BK Survivor did not survive. This is just a piece of crap compared to the other two. It's just, you know, there's no cat rating on this thing. It's a pain in the ass to change the fuse in there. The 1 amp, very expensive, $5, $10 fuse if that ever needs to be replaced. And it's just, you know, it does have my minimum 5 measurement features, but, you know, it doesn't really compare to these other things, which have, you know, all this other awesome stuff like hertz, and then there's the beta and capacitance test on that one. The fact that it's water resistant, that's overkill. I mean, this is not going to be anywhere near water in a typical engineering laboratory. This is totally ridiculous. I don't even know why they would. It's probably some marketing wank that they just decided to give it that feature of water resistant. I don't know. I mean, I'm sure it's got some good application, but for me, this is just totally out of the game. Now, as for these two, 2 amp fuse versus a 0.5 amp fuse on the low current range, totally awesome. 2 amp fuse, I would definitely go for that. And then there's the hertz range on this one, completely unnecessary as far as I'm concerned, because they would use the oscilloscope for any kind of frequency measurement. You know, any AC circuit at all. They always have function generator and oscilloscope hand in hand. They don't need the multimeter to measure frequency. And then over here we've got the beta measurement and capacitance measurement. The beta measurement for the transistor tester, that would come in very handy, because students very often, you know, they blow out transistors. They might hook up the base of the transistor straight onto the power supply and just totally blow it out. And it's, you know, it'll be very convenient for them to just plug it in here and check it, just to make sure that they actually have a reasonable beta. And then the capacitance measurement, that would certainly come in handy in lab for students, just to, you know, check to make sure that they have the right capacitance value. If they don't understand the 3-digit code that very often is printed onto capacitors of 0.1 microfarad or less, you know, they very often don't know that or don't recognize that. And so that, you know, this would come in handy to you know, at least to measure the capacitance, because they always loved to measure capacitance. I mean, even in my undergrad days, I remember that, you know, it was always, for me, for any undergrad student, it's always a big deal to measure everything. You want to check all your components just to make sure you got everything right, and you want to get your percent error as low as possible in the conclusion of your lab report. That's the mentality that I've experienced. And so capacitance measurement in the lab room, no big deal. Plus, they use fluke multimeters, the 189 and the 87.5. Those also have capacitance measurement on them as well. The AC/DC button selector right here for the two, you know, voltage and current, versus straight up selection on the knob for AC or DC. That's no big deal. I don't see any concern about that. After all, that is how it is on the Keithley 169 has DC AC selector switch right there. Students are already accustomed to that kind of configuration, so there's no big deal to have another one of those switches on the multimeter. The final thing to consider is true RMS. This one does not have it. This one does. So, you know, which one am I going to pick? I think I'd go for the one that's lower cost. The $139 from DG Key versus $199 for that true RMS capability. And this one actually has, you know, the two very useful functions, the beta check and the capacitance tester, whereas Hertz, nobody's really going to make good use out of that. So I think that settles it. I'll turn this one off. This is the only one left in the on position, so that's it. The BK Precision 388B is what I have selected out of these three. I may do some more shopping around with different brands. I know there are plenty of different brands and different types out there. I mean, I've seen all of Dave Jones' videos about his multimeter shootouts, but that was a long time ago. And really, you know, I just got to limit myself. I got to establish some kind of constraint, just like what they've talked about on the amp hour multiple times. You got to have some kind of limit. And I just decided to stick with the one brand, BK Precision, because you see that in all the Jameco and Electronics Express catalogs. It's really out there, really popular brand, and I just decided to go with that. Look at the three of them here that meet my requirements, these 5 requirements right here, and then pick the best one based on all these other features right there. I'm still open to suggestions. If you have, you know, a good substitute, you can put it in the comments below, but chances are by the time I get this up on YouTube, I will have already purchased a bunch of these things right there, the BK Precision 388B. After all, I do have a limited budget to work with, so I could, for the same, for a given amount of cost, you know, I could purchase 20 of these things for the same amount of price as I could purchase 14 of these. That's the relative distribution of price, 139 versus 199 relatively on DigiKey. I'm just using that as a ballpark. I'm sure, you know, it'll be slightly higher or lower from other distributors, and I might get some educational discount pricing too, maybe less than $139. I don't know. We'll have to see how that works out. But anyway, I've decided to go with this for the moment, and that's the winner of this particular shootout of the 3 different multimeters. Again, just for my purposes, for bulk buy, for general student use, that's the best one. These, you know, they certainly have their advantages and disadvantages, just like any multimeter out there, especially if you want to buy just one by itself. Definitely go for a Fluke, you know, if it's just one multimeter, a Fluke or some other higher end brand like that. But these things, you know, that's what I'm looking for, and that's what I'm going to get. So if you learned something, please give this video a thumbs up, and I will see you later. Bye.